Hello everyone, my name is Vivek Dixit and today is the day 5 of data science series. So in this series we will discuss unit 5th model evaluation, how to perform model evaluation using Python. Model evaluation is a critical for understanding how well a machine learning model performs on unseen data. In Python, various matrices and methods help evaluate model for different tasks such as classification, regression, and clustering. Here is a guide on how to perform model evaluation in Python using scikit-learn. So, the first step is classification model evaluations. The common metrics for classification include accuracy, precision, recall, F1 scores, ROC, AOC, and the confusion metrics. These all are topics we will cover in this series. So let's start it. The first step is split the data. So how the data will be split into the into the model evaluation. So this is the code to split the data of the code. Second step is evaluate the model. So the fourth the fourth model we will cover accuracy, precision, recall, and F1 score. So the Python code is the from sklearn.matrices import accuracy score, precision score, recall score, and F1 score classification report. These all are the functions will be generated to this code. So the example of this code to this area. This is the example of the code to the precision, recall, and F1 score. So next topic is confusion matrix. From sklearn matrix import confusion matrix. Import C1 as SNS. This is called matplot library function. So the confusion matrix will be created to this codes ROC curve and AOC for binary classification. For binary classification, you can plot the ROC curve and compute AUC. This is the code of the binary classification example. ROC AOC score and the plot ROC curve. Regression model evolutions. The second topic is regression model evolutions. For regression, common matrices include mean absolute error, MAE, mean squared error, MSE, root mean squared error, RMSE, and R square. This is called coefficient of determinations. So, how to create a regression model evolution? So, the procedure will be step by step. The first step is train a regression model. How to train a regression to the model uh, in a evolution of to the data science. So, the code to the model regressions and the regression model. Step 2, evaluate the model. How to evaluate the model to this code? So this is the example of the model square code. So we will let's try to this code. Firstly, we copy to the code and this is the handwritten codes we will provide in the descriptions below. All codes will be provided by the descriptions. This is a mean absolute error because this value not generated will be this is r square 1. And the third topic is cross validation for model evaluation. A cross validation provides a robust way to evaluate model performance across different splits of the datasets. Here we can see the code of the sklearn cross validation model. This code provides a cross validation method to the code. We will import cross validations score. Fourth is grid search and hyperparameter tuning. To optimize model performance, use grid search to find the best hyperparameters for your model. Python code. We use in Python code because data science everywhere R and Python functions will be provided. All of the summary are classification evaluate using accuracy, precision, recall, F1 score, ROG, and AUC, and the confusion matrix. These all are the functions of classifications, and the regression use MAE, MSE, RMSE, and R square for evolutions. Cross validations and research we will provide shortly, accounting for unequal error cost using Python. In many real-world applications, the cost of different types of error varies. For example, in fraud detection, missing a fraud case, false negative may have a such higher cost than incorrectly flagging a legitimate transactions as fraud. False positive, in such cases, traditional accuracy matrices may not suffice, and you need to account for this unequal error cost in model training and evolution. Here is how to handle unequal error cost in Python, particularly for classifications models, using class weight in scikit-learn. This is the most classifier in scikit-learn, like random forest classifier. We will discuss previous lecture how to random forest classifier will be created and logistic regressions and SVM support a class weight parameter. By setting this, you can give a higher importance to certain classes to the address the unequal cost associated with misclassifying them. This is the code of the this is the code all of the data sets and split the data set, make predictions and evaluate. All the codes will be provided manual weighting of sample using sample weights. If you have a data set where individual samplers carry different misclassification codes, you can use sample weight during model training. This provides more flexibility or unequal error cost that vary on sample by sample basis. We will discuss all the definitions and the code will be shortly provided. Custom loss function with unequal error cost. If using a model like XGBoost or LightGBM, which allows custom loss functions. You can implement a custom loss function to address unequal error cost. Example with XGBoost, we have taken this code of this example. This is the XGBoost example. All the commands and the Python codes shows the functions to the unequal areas. Loss, spreads, something else. Cost-sensitive evaluation matrices. After training, evaluate the model with a custom confusion matrix that accounts for cost or use a custom matrix function that multiplies the counts of false positive and false negative by respective cost. Simply, we copy of this code. This is the Google Colab site to use coding purpose. This is the area of the coding generated. Class weights and sample weight allow for adjusting model training to account for misclassification codes. For models that support custom objective functions, use a custom loss to directly integrate error cost. Evaluate model performance using cost-sensitive confusion matrix or custom cost calculations. This method helps your model priorities accuracy where it is matter most, reducing overall misclassifications cost. So, in this topic, all the topics will be covered to the model evolutions. This is the most important model chapters for the purpose of data science to how to perform model and using Python language and R language. This is the all of the code provided in the descriptions below. and download, go to download to the page. Thank you.